Hello, in this video, I will explain to you on how to solve this problem. Let's read the problem first. Number 1, a certain orthodontist uses a wire brace to align a patient's crooked tooth as in figure P5.1. Okay, so this is the figure. And the tension in the wire is adjusted to have a magnitude of 80 Newton. Okay, so we will have these two forces and each of it is 80 Newton. And this one also 80 Newton here. And then find the magnitude of the net force exerted by the wire on the crooked teeth. Okay, so the net force here is the sigma F, right? In the Newton's second law. So we'll have sigma F there. Sigma F is equal to the mass times acceleration. Okay. But then we have two directions here, on the x-axis and also on the y-axis here. So we need to project both of them here into the x-axis and also on the y-axis, right? Okay, now let's see here. Let's project this t here to this x-axis. And so we will have this force there. Okay. And that will be t on the x direction. So I have tx. And again, the same here. We can also project this one here to this direction here. So we will have tx also there, right? But then we can also project this force here to the y direction. Okay, let's use green maybe. So we will have this one here, the left one. We will have this one here, which is our ty here, ty. But then we also have from this force here projected into this one. Okay, maybe let's use different color. So we will have maybe in orange. So we will have another force here that will be our ty. Good. And let's analyze the force on the x direction and also on the y direction. So we'll have on the x direction. Okay, on the x direction here, we will have this one here, tx goes there, and also tx goes there. So in the x direction, I will have the net force in the x direction here. That will be this force here goes there. So I will have tx. And then we also have this one here. So I'll have minus tx. So in the x direction here, I will have 0, right? I will have 0 resultant forces, and the unit here is in Newton. Good. Okay, we don't need this m and a actually, because we only need to find out the net force here. And let's do that on the x direction. Okay, let's do that. Let's do on the y direction. Okay, let's see here on the y direction here. So I will have the sum of y like that. And the positive direction is there. And so we will have the negative direction here. So we will have that one will be minus t on the y direction. And then minus t on the y direction. Because we have two forces, right? The green one and the orange one. Good. So we'll have the f on the y direction here. That will be minus 2t on the y direction. But then we can calculate t in the y direction, right? Because this is here, and also that can be written here, right? So that also help. Because why? Because this is the opposite of the angle, and here is the hypotenuse. So we will have opposite and hypotenuse. So we will have our ty here. If we imagine this t here as our hypotenuse, we will have hypotenuse and opposite, so we'll have sine, right? Because sine is the opposite side divided by the hypotenuse. So I will have t sine theta. And what is theta? Theta is 14. Right, so we'll have 14 degrees. And what is t? I will have 18, right? So I'll have 18 sine 14 degrees. Okay, so we can just plug that in. So we'll have minus t. Ty here is 18 sine 14 degrees. So I'll have this multiplied by 18 and then sine 14 degrees. Good. And so I'll have minus sign here, and let's just use calculator to calculate that. So I'll have 2 multiplied by 18 multiplied by sine 14. And we have already the unit is in degrees. So we will have 8.71 minus 8.71. And the unit here will be in Newton. Good. And this is on the x and y direction. So we will have the net force here. Okay. So we will have our net force. Maybe let's write it here. What is our net force? Because on the x direction we have 0 Newton, we only have on the y direction. So the net force here, that will be minus 8.71, but then that will be on the j direction. Good. But we are asked to find out the magnitude of the net force. So we can just take the absolute value of this one. So we'll have sigma f here. Because there is no angle, we have the direction going into the y-axis here. We will have 8.71. And the unit here is in Newton, right? So that is the magnitude of the net force. And I think that's all for this problem. We have the answer here, 8.71 Newton. Hopefully I did not make any mistakes during my calculation. Thank you for watching. See you in the next video. Bye bye.